objective that we have is going to be C, and we're going to talk about connectedness, reachability, and connected components. So I have a graph on here. It looks very similar to the graph that we had when we were doing objective B, only now I've added a little bit more to it, in that I added 4 new nodes, and then I put an edge between like the old part of the graph and the new part of the graph. All right, so the first thing that we're going to do is talk about what it means to be reachable. All right, so for example, let's just use the letters that I'm using in this particular graph here. Let's say S is reachable from W, which it is, and the definition of reachable means that just by starting at that one vertex and moving along the edges that are provided, you can actually reach that final node. All right, so in this case, S is reachable from W if you follow along the edges, and you can say, okay, well, from W, I can go to U, I can go to V, I can go to R, and finally I can go to S. As you can see, all I did was follow along edges that were provided in the graph. All right, and so that means that S is reachable from W. The concept of reachability is going to be important in the concept of connectedness, because this means that the entire graph will be connected if all the edges, if all the vertices are reachable from every other vertex. All right, so in this case I said, well, S is reachable from W because there's a path from W to S. The way I've drawn this graph, doesn't matter what name I put here. As it turns out, all the vertices are reachable from all the other vertices within that graph, which means this is a connected graph. Bam. All right, so this graph is connected because it doesn't matter what vertex you say is your start point and what vertex you say is your end point, because there's always going to be some sequence of edges that you can follow in order to go from that first vertex to that final vertex, which means that it's connected. But what if I was being really malicious and I said, in this graph there's no edge from V to R? All right, well, in this case, not all the components are reachable from every other component, so this graph is no longer connected. But we do have the concept of these parts of the graph being connected. So you can see here, with this little segment of the graph that I've written, for example, Q is reachable from R, and S is reachable from Q, and Y is reachable from S, so that little portion right there, you can say, well, that's connected. And then if you look at the top up here, you can see, well, all of these nodes are connected to all these other nodes in this segment. Those are all reachable from one another. However, the graph consists of all these vertices, so the entire graph is not connected, but it does have connected components. So the connected components just means that there's like some subgraphs, and those subgraphs are going to be connected with one another. So in this case, I wrote V represents all the vertices. Let's say that the top section is represented by capital U, and the bottom section is represented by Q. So in this case, V is the disjoint union of U and Q, where U and Q are both connected components. And remember, this goes back to our objective A, in which we talked about subgraph. U is a subgraph of V, and Q is a subgraph of V. In learning objective C, we talked about reachability, connectedness, and connected components. A vertex V is reachable from U if there is a path, a sequence of edges from U to V. A graph is connected if there is a path between any pair of vertices. And finally, connected components in a graph are subgraphs that are connected.